Alright, so we're going to look at air pressure again, but then kind of finalize this and how this plays in with wind and what air pressure has to do with it. So as a review, remember that more dense air is going to be heavier for the same size. So if we take a look at our air here and our air here, well, they're the same size, but the density over here is much more. So we have more air particles. So obviously that's going to push down more. In other words, it's going to be heavier. So if we were to put them on these two scales, it's going to push that scale down more, and it's going to be like this situation over here. So more dense here is going to have a greater amount of pressure. In other words, it's going to push down more. Now, air pressure is also related to temperature. So when we're looking at colder items, like our ice cubes over here, okay, well, that's going to cause more dense air particles above it. That's what we see here. So these air particles are really close together. Because they're really close together, they're heavy air particles, so it's going to fall or sink. Whereas over on the other side, if we have a hot situation, well, that's going to cause our air particles to be farther apart for the same amount of area. In other words, it's going to be less dense. That means we have a low pressure. Well, low pressure air is warm, less dense, and it's going to rise. Okay, and so we see that in this simulation here. So when we press play and we add some heat, well, that's going to cause these air particles that are really close together, that have a high density, okay, to spread apart, to move faster. Now they have a low density and they rise. Okay. Well, that's what a low pressure is. High pressure would be the exact opposite. So if we add ice to it instead, well, that's going to cause these particles to slow down, to become more dense, okay, and so they're going to take up less space, they're going to sink or fall. So things with more pressure, higher densities in other words, will sink, and that's what's happening here. All right, so what does air pressure have to do with wind? Well, that's what we're going to tie together now. So remember that the sun is going to heat the Earth's surface unevenly. So our sun's light comes down, and it's going to strike the land and the water. However, it transfers heat unevenly. So over here, it would be warmer, and this would be cooler. Well, right there, this causes then differences in our air particles. So the air particles above the land will be heated more, well, they're going to be farther apart. That's going to cause it to have low pressure. In other words, a low density. And low pressure items will rise. Whereas over here for our cooler water, well, that's going to have air particles up above it that are really close together, high density. Well, that means then that these guys are going to fall. As they hit the ground or the surface, they'll start to spread out in different directions. And so we get this high pressure not only falling, but also moving into the low pressure areas that were released by our warmer air. Well, the same thing is true with our low pressure air. So as it reaches higher and higher into the atmosphere, it's going to start moving off in different directions. So we get this convection current going on, all because of temperature, density, and pressure differences. So this visualization shows it really pretty well. So again, as high pressure air sinks, well, it can't go through the ground. So it'll start to move off in these different directions, and we get wind. Whereas low pressure has low density, so it's going to rise and move out. So air pressure always flows from our colder, so that's what we have over here, our colder, more dense, higher pressure areas, see our arrows then here, to our warmer, lower density, lower pressure areas. So it always goes from an area of high pressure to an area of low pressure. Now the next slide will look into this in more detail, but it's going to follow this line of thought that we just talked about. So we see this happening with our more of a three-dimensional picture that we have here. So you can imagine the sun heats up, of course, the earth unevenly. So over here, this ground would be warmer, and this would be cooler. Okay? Well, that then causes the air particles to be warmed above it, so they're going to be farther apart. In other words, lower pressure here, closer together, a higher pressure over here. Well, low pressure items, of course, are going to rise. Okay? High pressure items would fall. Well, it can't go through the ground, so it starts to move. It's going to fill in this area over here that was vacated or left by our low, warmer, high pressure air over here. So things always move from an area of high pressure to an area of low pressure. Otherwise we wouldn't have any air. This is how wind works. High pressure always goes to area of low pressure. Now when you watch the news, you'll see something more like our picture over here on the right-hand side. Low pressure, okay, which is occurring here, well that's this, if we could see it three-dimensionally. So this is going to be warmer ground, okay? That's this right here, warmer ground. That causes the air particles to be farther apart above it, less dense, less pressure, and rises. Okay? So here you can imagine it's rising. Well, eventually it can't go any higher. It does cool off as it rises and gets farther away from it. Cools and cools, becomes more and more dense, more pressure, and falls. Well, that's what's happening right here. It's rising way up in the air and falling as it becomes more dense, more pressurized. Then it's going to start moving this way. So you get this convection current going on, which is what you're seeing really over here. That's wind, or convection currents. All right, so the last thing we're going to look at is what causes stronger winds. So one of the things that causes stronger winds is just a greater temperature difference between where it's hot and where it's cool. So remember, Earth is heated unevenly, and so some places are going to be warmer than others. So this would create winds that would be rising and falling, going from one place to the other at a slower rate than the winds over here because this temperature difference is greater. So greater temperature differences cause greater or stronger winds. So these would just be moving faster, these would be moving slower. The last thing that causes stronger winds would be the distance between our low and our high temperatures. So when they're really far apart, between our cold and our hot, well, it's going to go slower because there's a greater difference. So we would have weaker winds here. Whereas here they're really close, so our winds would be moving much, 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 much faster.